Good morning, sir. My name is J. Rohini. I am from ECB section and my roll number is 234G1A0496 and here my topic is about bipolar junction transistor operation. Introduction to bipolar junction transistors. Bipolar junction transistors BJTs are semiconductor devices that can amplify current. They consist of three regions: emitter, base and collector. BJTs come in two types: NPN transistor and PNP transistor, which define the direction of current flow. In this picture we can say that this is the base, collector and emitter. Collector is P type, base is N type and emitter is P type. It is NPN transistor, base, collector and emitter. Structure of a BJT. A BJT is made up of three layers of semiconductor materials, each doped to create N-type region or P-type region. In an NPN transistor, the emitter is N-type, the base is P-type and the collector is N-type. Conversely, in a PNP transistor, the layers are reversed with P-type emitter and collector. Operating principles. The operation of a BJT is based on the movement of charge carriers like electrons and holes. In active mode, the base emitter junction is forward biased while the collector base junction is reverse biased. This creates a condition that allows a small input current to control a large output current. Current flow in NPN transistors. In an NPN transistor, electron flows from the emitter to base when the emitter base junction is forward biased. A small portion of these electrons recombine with holes in the base while most continue to the collector. This results in a larger current flowing from collector to emitter controlled by the base current. We can call it as IE is equals to IB plus IC. Current flow in PNP transistors. In a PNP transistor, holes from the emitter to the base when the base emitter junction is forward biased. A small fraction of holes recombine with electrons in the base while the majority move to the collector. Consequently, this enables a large current flow from emitter to collector modulated by the base current. Operating modes of BJT. BJTs can operate in three distinct modes: active mode, cutoff mode, and saturation mode. In active mode, the transistor amplifies signal. In cutoff mode, it acts as an open switch. In saturation mode, the transistor behaves as a closed switch, allowing maximum current flow. Here in active mode, we connect input section in forward bias and output section in reverse bias. In cutoff mode, both are in reverse bias, and in saturation mode, both are connected in forward bias. BJT characteristics curves. The output characteristics of a BJT illustrate the relationship between collector current and collector to emitter voltage. These curves are essential for understanding how the transistor responds to varying base currents. The regions of operation like active region, saturation region and cutoff region are clearly demarcated on these curves. Here we can have this graph. On x-axis we take VCE and y-axis we take IC and IB as constant. We can get three regions mainly: saturation region, active region and cutoff region. We can also get that breakdown region. Applications of BJT. BJTs are widely used in amplification applications such as audio amplification and radio frequency amplifiers. They are also serve as a switch in digital circuits, enabling control of larger loads. Additionally, BJTs are crucial in signal modulation and processing in communication system. Advantages and disadvantages of BJTs. One advantage of BJTs is their higher gain and ability to handle large currents. However, they are less thermally stable compared to field effect transistors (FETs). Furthermore, BJTs require more complex biasing circuits to ensure stable operation. Conclusion and future trends. BJTs remain fundamental components in electronic circuits due to their robustness and versatility. Ongoing research focuses on enhancing their efficiency and integration with modern technology. Understanding BJT operation is crucial for students and professionals in electronics and electrical engineering. This concludes the slide presentation on bipolar junction transistor operation.